As you might have noticed, I'm Gavin Dowdy. I'm an engineer on the AdWords mobile app at the Google office in Los Angeles. I've been working with Flutter for about the last year, and I'm here to tell you something about it. I'm going to show you how the Flutter SDK works really well if you're building a reactive application. I'm going to show you how its programming language, Dart, gives you some really good core language level primitives that you can build up reactive data systems with. And I'll show you a few practical tips that we've learned building an app with Flutter over the last few months. I don't think I'm going to lose many of you guys, but I expect you to understand object-oriented programming and know what a function is, particularly functions that can return other functions and take functions as parameters. That's because I'm going to show you a little bit of code in the Dart programming language. I think you'll find Dart quite familiar, but I'll try to highlight the relevant parts as I go along. Now, I've been at Google for about 11 years. I worked on web for the first 5 years, and then I worked on native iOS development. Around the same time I started working on native iOS development on things like Google Plus and Google Photos, I also had a kid, my youngest kid, around 2011. And I always have some little hobby project cooking on the side. But when I had the kid, I was like totally busy. I was just like day job, fatherhood for several years. And it turned out these were bad years to miss in web development. I wanted to get back into doing some hobby web projects just to experiment with things. Let me show you the little testbed application I was using for this amazing application. It's a little tic-tac-toe game that I was using to figure out different web technology stacks after being away for several years. You can play a robot AI, and if you're on the internet, you can play another person live over the internet. So this was my testbed application, because what I was really interested in was live data. This idea that data is going to be changing in real time, potentially by multiple users. So things like chat apps and collaborative editors and multiplayer games, these are all kind of live data applications, and I thought they were really interesting, and I wanted to have some pretty good tooling to start out with for live data. And as I dug into live data, I had this realization, which is that all data is live data. So as programmers, we like to lie to ourselves and pretend that the data is going to change when it is convenient for us to have the data change. But inevitably, we get it wrong. Mountains crumble and stock market prices fluctuate, and your application data changes somewhere on that spectrum, but you never get it right the first time. And if you don't design your application for it right away at the beginning, you'll be in for a lot of trouble later when the real world characteristics of the application suggest that it's going to be changing on some other time scale. So I kind of missed out what had happened in the front end after 2011 when my kid was born, and I came back in, and it's like, wow, all this stuff has happened in such a short time. You not only do you have things like web components and service workers, but also Webpack and Babel, and it's like, wow, there's just an explosion of technologies to look at. But there was also this architectural sea change, which I'm sure you guys are all familiar with by now, and that is reactive programming. So I started looking at, how React worked and Elm and all of these kinds of systems, and they kind of blew my mind because they aligned really perfectly with this idea of your data always changing. So I want to share with you my little model of what I consider the reactive programming. This is not particularly original, but you start with some piece of state that's coming from all the users in the world, maybe, and you produce the state of your application. The UI renders that state to create a view, which the user then interacts with to produce events that are combined with the state to produce a new version of the state, and the cycle continues. Now, you can simplify this a little further and just say the user is a pure function of the UI. The user function input is the user interface, and the user's output is a stream of events that change the state. So I want to say, hat tip to Andre Stoltz for coming up with that. You should go watch his talk. And then this middle section, when you're rendering the state and when you're handling the user input, that piece is your reactive UI system. And that was the missing piece that started the flood of being able to reason about your application as this flow of data. So I'm working on this, and I'm having a lot of fun, and I'm doing this fluid development, and I'm talking about it at work a lot and saying, this is great, this is amazing. But at work, I'm still doing your classic model view controller programming, so I'm sad. But then my team lead comes up to me and says, I've been hearing you talk about this reactive stuff for a while. I want you to take a look at this Flutter thing and see if we can use it for our app. And I started looking at what Flutter was and how it worked. And I realized that Flutter, one of the things it was really designed to be, was a reactive UI system. So, happy Gavin. So, how many of you heard of Flutter before? Wow, man, not nearly enough. So, mile-high overview, kilometer-high overview since we're in Europe. It's a full application SDK. You use the Dart programming language. You use the Flutter SDK and the Flutter APIs to write your application. It gives you a really nice developer ergonomics. But you deliver an ARM binary, a compiled machine code application to both Android and iOS. So it's a cross-platform SDK. It's just the same as you would if you were writing in Objective-C or Swift or C++ or something. It's got a really complete set of widgets. You generally don't have to write your own widgets for the sort of standard UI components. They're very complete. But we don't pretend that there isn't an underlying operating system. So there's a plugins interface that you can use. So you can take native code and access platform level functionality, and you can also use code that you've already written if you've got native mobile code. And finally, it's a reactive framework. It uses the reactive idiom for rendering your user interface. In a lot of mobile development systems, the code that is running when your application runs, there's a fairly small percentage of it that is accessible to you, the engineer. You don't really have a lot of insight into how UIKit renders the views on iOS, or you don't have control of how the DOM itself operates, or how the compositor operates, or how the style sheet system operates. You're using it through a fairly small piece of that code is yours. Flutter kind of flips it on its head. Flutter starts with a very low-level primitive layer. It's the text rendering subsystem from Google Chrome. It's a very mature text rendering subsystem. It's multilingual, and it does nice fonts and all of that good stuff. It uses the Dart runtime, VM, and libraries. Dart is a high-performance language interpreter that was written by some of the original engineers on the V8 interpreter team, so it's a really kind of the next-gen language. And then it uses Skia, which is a portable, hardware-accelerated graphics layer. And it does the very primitive graphics operations like blitting and drawing lines and filling and things like that, so very low level. On top of that low level, it's all exposed as the Dart UI package. The rest of Flutter is built, and that includes not just what you'd expect, low-level primitives, but all the way up into the widget and style widget system. So everything that you would normally think of as kind of off limits to you as an engineer is available to you in Flutter, so you can hook into it. And unlike systems like where you are programming in JavaScript, say, and then you are driving the native UI system with your code and pushing code back and forth across a bridge to the underlying platform UI system, Flutter keeps all of that code on sort of its side of the wall. So there's no bridging, and you get really good performance that way. Now, I was really excited to be able to build a reactive system at work, but I was also pretty skeptical that you'd be able to get something that looked and felt nice, because a lot of the other cross-platform systems I've used in my career kind of always left me wanting a little bit more. But I did just what you guys can do tonight, is downloaded the Flutter SDK, I built the sample applications. This is one of them, this is a gallery application. And I was like, okay, these are great. These are running at 60 frames a second. You can do these really nice designs and animations with it. Animated GIFs don't actually run at 60 frames a second, so if you want to get a feel for the native look and feel, you can download the SDK. If you don't feel like downloading the SDK, you can actually download this app. It's the Hamilton app. It's available in the App Store. Since we're not in the States, Hamilton is one of our presidents. there's a really successful Broadway musical production, live musical production about this guy. It's a rap opera about President Hamilton. It's been selling out for years now. It's like completely sold out theaters. And they, the producers of the play contracted with a digital agency in New York who wrote this application using Flutter and Firebase, and it's the application you can use to submit yourself to a lottery, to win a chance, to spend hundreds of dollars for a ticket to a Broadway show. It's kind of interesting because they didn't choose either material design or iOS as their UI metaphor. So they've got more of a branded UI experience, and they found that was very easy to develop with the Flutter system. So why were we interested in using Flutter? Flutter wasn't even officially in alpha release when we started prototyping with it. It is now. But we were particularly interested in it for a few reasons. One is we wanted a reduced API surface. Like our team is actually a fairly small team for like a mainstream Google consumer-facing application. And half of it was doing iOS, and half the team was doing Android development. And we liked each other just fine, and we were using the same data sources and stuff, but we couldn't really share code, and we couldn't share expertise, but we did have to have the applications be fairly identical on both platforms. So it was nice to say, okay, great, we're only going to have one API to target, and it's not going to be iOS or Android, it's going to be the Flutter SDK API. Similarly, we were able to say it's just going to be this one language, so we can share some expertise and we can share some code between ourselves, and we don't have to be expert in both Java and iOS. And finally, we had quite a bit of existing Dart code, and this is kind of a bonus round here. There are a lot of Dart code running in production for major applications inside of Google. So we were able to leverage some of that expertise and some of that code. But that's not really required if you want to take advantage of Flutter. I only mention it because a lot of that code has been open sourced. So you're not doing a cold start. You've actually got quite a lot of libraries that are available. Dart has a nice packaging system akin to NPM. So you can get a hold of these Dart packages and write your own. But one of the other major reasons we were interested in using Flutter was simple developer happiness. Our large mobile applications were taking several minutes to compile. You'd go and you'd have to navigate to some sub-view and make sure that you've changed the fonts or the spacing or the layout to be correct for that view. And if you didn't, you'd have to rebuild and re-navigate down to that view. And Flutter has hot reloading. So as you might be comfortable with from other environments, you can do this for high performance native mobile development as well. And a couple of nice things about hot reloading in Flutter is the way the system is architected, it preserves state. So you can hot reload in under a second, and it will preserve the state of your application. You see there's a little counter number going back and forth, and when they change the text, it will maintain the state. Another nice thing about Flutter hot reloading is if you make an error, you'll see debug information for that widget that had the error in it. This particular widget is taking up the whole screen, but it could be just some sub-widget on your UI. And you'll see debug information about the widget, and you can usually correct it and reload again, and it'll just keep going. So that's a really nice productivity thing. That's code, isn't it? We're not seeing nearly enough code, are we? So I started learning Flutter, just enough Flutter to write a prototype for our app, and I started right where you probably will with widgets. And widgets are the overriding metaphor in Flutter. So it's like files in the Unix systems. They're sort of a metaphor that's used for things you wouldn't necessarily expect them to be. So everything in Flutter is a widget, including things like visual styling and animation are all widgets. And you compose these widgets in deep hierarchies of simpler objects, and the Flutter runtime system makes that efficient. So let's take a look at a really simple widget. This is like a labeled value. It's got a label, it's got a value, it's got some default padding around it. Here's the source code for that widget. Just a couple of things. It's got a couple of member variables. They're marked as final, which would be equivalent to ES6 const. It's got a const constructor, which means once you construct this object, it's never going to change. Widgets are always immutable by default, but you can even mark them const at a language level. And then all it's really responsible for is returning a tree of other widgets that will then be composed. So this is maybe equivalent to a pure functional React component. You know, if you want to expand the padding, you could just introduce a padding widget around everything else. So it gives you a single model, a single semantic model for doing your styling, as well as rendering your UI. If you do have state, like this nice material design slider that's dragging back and forth, it has some state, which is the current position of the slider in numeric space. And then that floating point value is being rendered in a label. So this is called a stateful widget. A stateful widget doesn't produce the render method directly. It produces an object called a state object that then implements the render method. State objects stick around between widget rebuilds. So the state in this object is just a value, a floating point value. And when you implement the build method now in your state object, the state keeps building this widget tree, you can use that value. So it keeps the stateful value of your widget together with the code that builds the UI. And that's actually all that Flutter provides at a conceptual level. It's got a really rich library of these things that do a lot of stuff for you. But that's really what you need to know to get started building. So knowing this, and having worked a little bit with React and Redux on my hobby projects, I built a prototype in a couple of months. And I want to tell you, though, most of that time was doing application infrastructure work to, be able to use it from Dart and to work with our build system and stuff. There's a lot of kind of heavyweight infrastructure at Google for writing these super scalable applications with really large teams. The Flutter part was kind of the fun, lightweight part. And here's a little screenshot of the application, the prototype application. And you see, like, the animations are pretty smooth, and the UI looks pretty nice because I'm using the out-of-the-box Flutter widgets, and it's actually making a live data query against our production servers. It's a fake account, so that's nobody's real data, by the way. So how'd I build the prototype? I started with the out-of-the-box widgets. I used the core library for HTTP to do the networking, to do authenticated HTTP fetches against our production servers. I used the Google authentication plugin. So if you want to have your users authenticate to their Google services, you would use the same plugin that I did for the prototype, and it pulls up the permissions page that they have to agree to and all of that. You don't have to write any of that stuff yourself. You just get the correct token back. And I used a Redux data store. I used a port of Redux called Green Cat, and that worked just fine. It worked just like you'd expect it to. So this was convincing enough that we decided we would start work on a production version of our application using Flutter. But one thing that became pretty obvious to us is that we had some complicated asynchronous logic going on. So I just want to go into detail for a second about this table view. You can say it'll resort when you click on one of these column headers. You can scroll past the currently loaded page of data and just keep scrolling. And eventually, when you stop scrolling, it'll load the next page of data. So you can whip down to the ends of these multi-thousand line lists, and it'll fetch extra data for you. And it will also filter by that date range at the top. It'll filter your queries by that date range. And all of these user interactions and all of these network interactions are fairly complicated to coordinate. And we looked at a bunch of solutions for this. And what we decided to use was observables. So there's a port of the observables library. It only took about 100 lines of code to do that. That's blurred out because it's not open source code. But that's really about what the code looked like to do all of those interactions with that table and all that complicated async logic. That's like a snippet, a readable snippet of it. But you can see it's very similar to how you would chain operations on collections in JavaScript, say. It's just very straight line, and you're declaring a lot of interaction. This is taking the virtual list scroll index. That list is virtualized, so it's not doing a lot of extra work that's not on screen. And using the observable for the scroll position of the list to drive the creation of a network RPC request that asks for a specific page of data. So it's doing kind of a lot of work, but it's all kind of packaged up in this nice It's too much, that's too complicated, isn't it? We're going to do this widget instead of that list. So I can show you what observables look like when you're coding. This is just a button. As you get a bunch of clicks on the button, and you add them up and render it inside the button. So it's just a little incrementing counter. These are all kind of trivial examples, and it's overkill sometimes to use streams, but it's easy to illustrate this. This is going to use the scan operator from Rx, from the observables library. This is a little animated Rx marbles diagram of how the scan operator works. It basically takes the last value produced by the stream and the new value and runs a function on them and outputs the results of that function. So this is all the code that you would need to do to implement a stream of this incrementing value based on clicks on the button. You see it's creating a new observable from the stream of clicks, and it's running the scan operator on it with this accumulation function. You can even play code golf on it a little bit and inline the accumulation function, because you've got some pretty compact fat arrow syntax for defining functions. So observables are just transforms on this data flow. And if you want to make your own observables, or if you want to be able to read the observables library in Dart, what you can use is the core Dart streams library. So let's take a couple of minutes and look at streams. This is kind of a contrived example, but again, it's this stream of clicks on a button. Down at the bottom, you can see you can subscribe to that stream of clicks and then call set state with an incrementing counter value. So this is the state of a stateful widget calling set state, so it'll be re-rendered. And here's how you build the button. They're just mapping the onPressed handler to push the number 1 into this stream. So the input stream that you're starting with is 1, 1, 1, 1, 1, 1, 1, coming asynchronously from the user, and then they're being added up. And there is a member variable getting updated, so I can call set state with it. But that feels kind of non-functional to me. So what you can do is you can move it into like a local variable, and then use it inside of the stream map operator. So this is just like map on an array, except instead of processing all the values in the array, it's processing them as they come in, as they arrive. And then I'm just calling this local closure that's incrementing the counter value and returning a stream of that value. But I'm not calling set state, because what Flutter gives you out of the box is the stream builder widget. And that's a generic widget that you can include, and it takes the stream that's producing some value and a build function that takes that value and takes a snapshot of the latest version of that value and lets you build your UI using that value. So you don't have to hold on to the state in your stateful widget. You just have to use a stream builder widget. And that will also take care of subscribing and unsubscribing to the stream and calling set state for you. So it's really the way to go if you're doing stateful UI. If you look at this map function a little bit, it's just a transform on the stream. So map is implemented with transform. Transform is an interface you can implement yourself. There's a handy stream transform operator here. I'm not going to go into this too much, except to say you could make a generic helper function. It takes parameterized types, so you don't have to work on integers like I'm doing in this example. And if you look at this implementation, you can see it's basically calling a reducer function with a state and an action, which is the core of how Redux does its thing. In addition to being almost all of Redux right here, this is pretty much literally the implementation of the scan operator in the Rx observables library that you get with Rx Dart. If you're using Rx Dart, observables are subclassed from stream, so you can pass one directly to the stream builder widget. And that's what we're doing with a lot of our code. So how are we using Flutter in our production app? Well, the first thing is we have a lot of business objects that represent kind of complex data flows and user interactions and network requests. And we're modeling those things as essentially named collections of streams and sinks. A sink is just how you input a value into the stream. So the public API for a business object would be, you put a value in here, and then there's a stream that you could subscribe to that might represent the result of taking that value and making a net request and transforming the data to make it convenient for rendering. And that connection is actually made using Rx observables. So the implementation of connecting the input sink to the output stream is through some arbitrarily complicated chain of observables. So we're using the observables library ourselves. We're also using the native streaming library. It sort of depends on the use case. We're using plugins. And we're not just using plugins because we want to access certain platform functionality. We do. But we also have quite a lot of native libraries that we've already implemented for Android and iOS for that have comparable functionality. For example, first-party authentication is a plugin, and there's Android and iOS implementations that we're wrapping up as a plugin, so we can use it in our application without having to write all this kind of complicated and maybe legally significant code to make sure we're authenticating people correctly. We're using a lot of Flutter widgets. We're contributing widgets back to Flutter. There was an engineer on our sister team who wrote an autocomplete widget that's going into the main Flutter library. And that's because we're relying on all of you. There's quite an ecosystem of reactive tooling already. Not all of it is written by Googlers. There's the RX Dart library that you can use. If you're into immutable JS, immutable values, I encourage you to take a look at the built value library. That uses some really slick Dart code generation, which is a whole other topic. But it makes it very easy for you to define a complicated structure of immutable objects and then efficiently produce new versions of that based on your desired mutations. And then there are Redux implementations. So this is the one you should use. It's the public Dart Redux implementation. There is a Flutter companion package. These guys are building out, these are not Google employees, but they're building out the Redux ecosystem for you. So you can hook up to a Redux store with Flutter with a minimum of boilerplate. So go to. And I just want to wrap this up and say, you've seen how applications might want to respond to data that changes on some unpredictable schedule. You can use observables to get a powerful vocabulary for declaratively describing how you want to react to these things. You can use Dart streams if you want a little more low-level power. I think Dart streams is going to continue to add things and maybe get up to parity with observables, so you can just use them directly. And you can hook it all into Flutter pretty trivially. Flutter is designed to work with data that's going to be changing rapidly. So you can take all of your reactive development expertise and start right away with Flutter. You don't have to reinvent your mental model of how this stuff works. You could just use mine. If you've got any questions about Flutter, if you download the SDK and play with it and have problems with it, you can ask me anything tomorrow at 2:30. There's also a talk about RX tomorrow at 5:30, so you want to really deep dive in observables. If you want to learn more about RX, you can go to reactivex.io. If you want to have those cool marble diagrams, they're at rxmarbles.com. You can learn more about Dart at dartlang.org. One of the cool things they have on that site is an interactive browser-based REPL for the Dart language, so you can just pull it up in your browser and try out code snippets in Dart, and it has a sharing functionality. We use it all the time. We use hey, how'd you code this up in Dart? And you're well, you could try this or you could try that, and you could send a link to somebody. It's really, really handy. And finally, if you want to learn more about Flutter, you can go to flutter.io and get the link to download the SDK for your platform, as well as a lot of really good polished documentation and API docs and so forth. Oh, okay, all right, I'm done. So thank you very much.